Okay, AP Stats. So, continuing on with 2.1, this video is going to look at specifically what happens when we do things to a data set. So, we may decide to add a certain value to all the numbers in a data set, subtract a certain value, maybe multiply or divide. If we already know certain statistics about the data set going in, when we apply these transformations, how does that affect our statistics? Now, we could just apply the transformations and redo our statistical calculations all over again. But sometimes, which you will get happening in questions, we won't have the original data set to be able to do this. So our question then becomes, well, how do we know what effect this will have? So I've gone ahead and I've created here for us an example data set. So 1, 2, 3, 4, 5, those are the numbers in our population. And I've gone ahead and I've calculated already the mean and standard deviation for that data set. So we're going to do a few examples of what happens to these values, to these statistics, when we apply a uniform transformation. So let's say, for example, we say that this is the scores on an exam. So as a teacher, I might say, you know what, I'm going to give everybody +2. So I'm going to add 2 to every data point. Okay, so obviously our data set then would look like 3, 4, 5, 6, 7. So it would look like this. Now, I could calculate now the mean and standard deviation for this. So the mean would now be 5, but the standard deviation, so if you calculated the standard deviation up here in your calculator, and you can go off to the side, pause the video, and do that to confirm, you would get this same standard deviation number here. Now, if you did it for this data set, you will see that the standard deviation is again going to be the exact same number. So by adding 2 to every data point, we see that the only number that changed, the only statistic that changed from the previous data set to this data set is the mean, okay, which is our measure of center. Notice that the measure of spread did not change at all. Spread stayed exactly the same. So a way to kind of think about it is that, let's say graphically our data maybe looked like this, with the mean being at 3. Well, if everybody adds 2, gets +2 given to each data point, all that's just doing is causing that exact same shape of graph to just be moved over 2 units. So the adding does not affect the spread. The data will still remain spread out the way that it was originally. And the same thing will happen as if we decide to maybe subtract from that. You can also see that the spacing between the points really didn't change. Every point here was spaced away 1. When we come down here after adding 2, that spacing remained the same. So again, adding or subtracting does not affect our spread, it affects our measure of center. So let's go ahead and we'll put that here. So adding and subtracting does affect center, but not spread. Okay, now what if we said, and as a teacher I might decide, you know what, I'm not going to add 2 because it might be too small. I'm going to go ahead and I'm going to multiply everybody's score by 2. So what effect would that have on my data set? So now I'm going to say, you know what, I'm going to multiply everybody by 2. So again, since I have the original data set, I can actually apply that times 2 to every point up here. So now I would say 2, 4, 6, 8, and 10. So now again, I can pause here for a moment for you guys to kind of work it out and put it in the calculator. And when you do, you should be getting that the mean is 6 and the standard deviation is now going to be 2.8 28. Okay, so now this time, and I'm going to zoom out here so we can have both numbers, you can see comparing the original statistics to the new statistics. So now this time both the mean and the standard deviation changed when I did this multiplication. Okay, so let's first talk about the mean. Well, what did we see happen with the mean? It was 3, it's now 6. So the mean doubled because we doubled all the data points. But also notice what happened to the standard deviation. The standard deviation also doubled because now what's happening, if you look at the original data points, you kind of get an indication of what's happened. The spacing between the points also doubled. So now notice 2, 4, 6, 8, 10. They each now have a gap of 2 as opposed to before it was a gap of 1. So now multiplying or dividing, so now multiplying and dividing does affect both center and spread. Okay, so now we can see, and if we know about what we just saw here with these effects, I really don't need to know the original data set. If I have the original statistics and I know the transformation that has occurred, I can now know what the new statistics are going to be without having to recalculate the entire statistics and get that new data set. So I'm going to go off here to the side and let's do an example of just that. So I'm going to take, for example, 1, and I'm going to say, okay, I went into a company and I noticed that the average salary, so I'm going to write here, the average salary is $27,000 a year. And there's a standard deviation of about $2,000. Okay, so now as the CEO, I might decide, okay, we finished out the year and I want to enact a bonus. So I decide I'm going to give everyone's going to get a $5,000 bonus. So now, if I do that, what would now be the new average salary at the company and the standard deviation for that average salary? So now I'm going to say the new mean and the new standard deviation. Okay, so what am I doing here? Well, I'm just going to give everybody an extra $5,000. So I'm going to add 5,000. So remember that if we are adding or subtracting, it's not going to affect the spread. The spread will still remain $2,000. But what's going to happen to our center? Well, if everybody went up 5,000, that means the center also moved up 5,000. So I'm literally just going to take my previous center and add 5,000 to give us our new mean of $32,000. The spread is unaffected because we didn't do anything to that. Now, I'm going to follow up and say, well, I'm thinking about doing this plan. But now let's say the union for the company comes in and says, well, we would like a different incentive package. Instead of giving us a flat $5,000, they would like that everyone get a 5% raise. So basically, instead of getting a flat amount of money, they want me to take their salary and multiply it by 1.05. Okay, so because it's a raise, so they're still going to get whatever they have before, and I'm going to give them 5% extra of what they have. So this is just a shorter way of writing that. So now this time, what would the new mean and standard deviation be? So now, and let me keep it blue here. So now the new mean under this plan, and what would be the new standard deviation under this plan? Okay, so we're going to take our mean, and now that we are multiplying both the mean and the standard deviation, will multiply now by this number. So for $2,700, and I just happen to have my calculator up and ready to go. So we're going to take our 2,700 times 1.05. So now it's 28,350. Okay, so I'm going to go back to my whiteboard. I'm going to write 28,350. But now the standard deviation has changed. It's going to get also multiplied by the 1.05. So times 1.05. So now the standard deviation has also changed. It is now 2,100. So now if we're comparing, so let's say, the bosses are pushing this plan, the union is pushing this plan, and then it's going to be left up to a vote to the employees. Well, which plan would the employees prefer? Well, under the first plan, we can see, well, average salaries would go up $3,200, but the spread, so we're seeing a much tighter spread here of the group versus here, well, the average salary went lower. So let's say here's the center from before and now the center from here. The average salary went up, but it wasn't as big of a hike here. But what have we done? Now I've increased the spread. So meaning I got a much larger spread of wealth here than here, where originally the spread was 2,000. It's still remaining 2,000. So when we do this percentage raise, then that's the thing that, as employees, as future employees, maybe for you guys, you have to kind of consider like, okay, I can take more money now, but really we haven't changed anything in terms of how many people are getting so much money. Okay. If you happen to be on this end of the spectrum, well, you're very fortunate. We're not getting the population here breaking out and going further over here to these ends of the spectrum. Versus in this plan here, well, okay, the average salary it went up, but not as much. But now the spread is starting to open up a little bit more. So now more people are kind of entering into these higher echelons. So this is where, people kind of weigh their options. Like, I'd rather have the money in my pocket now. It's great because everybody's going to get exactly the same amount, 5,000. Doesn't matter how many years you worked in here. Doesn't matter what your average salary is. You're just going to get a flat 5,000. So for those at the bottom, this might be a big incentive. But maybe if you're on the higher end, the 5,000, I'd rather get 5% of what I currently earn. So if you're a top earner, 5% is going to be way more than $5,000. But if you're on the low end, because remember, it spreads. So if you're on the low end, then guess what? More people will kind of be on this end too, because now the bottom group starts to kind of trickle in over here as well. So this is what it means that we spread the data out. So yeah, it increased, but then it spread out. So that's where we see this transformation of data. Okay, so notice here, I don't have any actual salaries to look at. I'm just using the transformation that's described to me to be able to tell you what the new mean and standard deviation are going to be. All right, so that was just a quick little glance at transforming data and how it affects measures of center and spread without having to recalculate the entire data set. So again, if you found this video to be useful, please make sure to hit a like and subscribe to the channel, and I'll see you guys in the next video.